Hello everyone, I am Dev Pateria from International Institute of Professional Studies, Devi Ahilyabai Vishwavidyalaya in Indore. So, today we are going to see the Endsem test paper or our Endsem examination solutions of computer-oriented numerical methods. This assignment and video is guided by Dr. Shaligram Prajapat. So, let's get into it. First question, write algorithm for evaluating the polynomial using brute force technique, improvise it using reoccurrence relation, compare performance of both versions. So firstly we will see the algorithm for evaluating the polynomial using brute force technique. So in first step, initialize the sum variable s to 0 for each term of the polynomial from highest to the lowest degree. A. Compute the value of the term by multiplying the coefficient with x raised to the degree of the term. B. Add the computed value to the sum variable s. Return the value of s as the value of the polynomial. Algorithm for evaluating the polynomial px using reoccurrence relation. This is a recursive approach. So, if the degree of the polynomial is 0, return the value of the constant term a0. Otherwise, compute the value of polynomial recursively by first computing the value of the polynomial of degree n-1 by calling the function recursively with the polynomial of degree n-1 as argument. B. Computing the value of current term by multiplying the coefficient with x raised to the degree of the term, adding the computed value to the polynomial of degree n-1. Third and final, return the value of the polynomial px. So second question is third part of the first question, which is write a program or draw a flowchart or write algorithm for finding the roots of a given quadratic equation. Consider all possible input conditions and all scenarios. So initially we will start, then we will input coefficients, then we will calculate discriminant, then we will check if discriminant is greater than 0. If true, go to the two real roots process. If false, proceed to the next step. In the fifth step, we will check discriminant if discriminant equals to 0. If true, go to the one real root process. If false, proceed to the next step. Now, if discriminant is less than 0, then go to complex root process. Seventh, which is a two real roots. Calculate the two real roots using quadratic formula, display the roots and the flowchart. One real root, calculate one real root using the quadratic formula, display the root and the flowchart. Complex roots, calculate the complex roots using the quadratic formula, display the roots and the flowcharts. And the last step is end, finish the flowchart. Second B, compare iterative methods on the basis of parameters, order of convergence, evaluation of functions as per iteration, reliability of convergence. Okay, so here are some iterative methods. So firstly, order of convergence, bisection method, linear convergence, order equals to 1, false position or regular falsy method, linear convergence in this 2, secant method, superlinear convergence where order is 1.62, Newton-Raphson method, quadratic convergence, order equals to 2, successive approximation, linear or sublinear convergence, evaluation of functions as per iteration, bisection method requires two function evaluation per iteration, regular falsy method requires two function evaluation per iteration, secant method requires one function evaluation per iteration. Newton-Raphson method requires one function evaluation and one derivative iteration. Successive approximation requires one function evaluating as per iteration. Reliability of convergence. Bisection method robust and reliable but converges slowly. Regular falsy method generally reliable but it may suffer from slow convergence in some cases. Secant method reliable with superlinear convergence but not guaranteed to converge. Newton-Raphson method fast convergence but may diverge or converge to a wrong solution if the initial guess is poor or encounters singularity. Successive approximation Convergence depends on the choice of the iteration function. If may converge slowly or not at all if the conditions for convergence are not met. Okay, write algorithm or program or raw flowchart for finding roots of equation x equals to x square minus x minus 1 using fixed point iteration methods. So here it is a flowchart. We will start with the start, set initial values x0, tolerance, max iteration, sorry. Second, initialize iteration counter equals to 0. Then second step, initialize variables, where we will set capital Xn to small x0. Third, iterate, calculate x next equals to x square minus xn minus 1. Then check if x next mod of x next minus xn is less than tolerance. If yes, root found, and if no, continue the next step. Fourth, update the variable, set xn equals to x next, increment iteration, check convergence, check if iteration is less than max iteration. If yes, then go back to iterate step. If no, root not found within the max iteration, end. And last step, end the whole flowchart. Okay, next question. Write a algorithm for Gauss-Jordan iterative method. Compare its performance with Gauss elimination method. Okay, so algorithm for Gauss-Jordan iterative method starts with the start, read number of unknown, read augmented matrix of n by n plus 1 size, transform augmented matrix to a diagonal matrix by row operation. So we have to make all the values of the diagonal 1 1 1 and everywhere else 0. Okay, then obtain solution by making all diagonals argument to 1 for each row from 1 to n. Normalize the row ai equals to ai divided by aii. Then display the result by result reduced row echelon from matrix A. Extract and display the solution for the system of linear equation, then stop. Now computational complexity. Both methods have a similar computational complexity of O n to the power 3. Memory requirement. Gauss-Jordan method might be slightly more efficient as it performs row operations in place of without needing for additional matrices. Efficiency. Gauss-Jordan iterative methods involve more iterations, making it less efficient for large system compared to Gauss elimination. Numerical stability. Gauss-Jordan iterative method may encounter numerical instability issues for ill-conditioned matrices. Solution uniqueness. Both methods provide solution for unique systems, but they may not handle inconsistent or underdetermined systems well. Ease of implementation. Gauss-Jordan iterative methods involve more steps of iteration, making somewhere difficult to implement compared to Gauss elimination. Okay, iterative methods are superior to the elimination methods. Write 4 disadvantages of Gauss elimination and write 3 advantages of Gauss-Seidel method. Okay, the superiority of iterative methods over the elimination method or vice versa depends on factors like system size, sparsity, convergence speed and memory, efficiency, and etc. Iterative methods excel in large, sparse systems with potential computational advantages, while elimination methods provide exact solution but may be less efficient or for certain scenarios. The choice hinges on specific problem characteristics and computational priorities. Disadvantages of Gaussian elimination or Gauss elimination. Computational complexity. Gaussian elimination involves row operation and matrix inversion, leading to computational complexity of O n to the power 3, making it less efficient for large systems. Memory requirement. The method requires storing the entire augmented matrix, which can be memory intensive for large system, especially if the matrix is sparse. Numerical stability. Gaussian elimination can encounter numerical instability issue, particularly when dealing with ill-conditioned matrix. Not suitable for sparse matrix, as stated in the memory requirement point. The method does not exploit sparsity in the coefficient matrix, which can result unnecessary computation for the system with large number of zero elements. Advantages of Gauss-Seidel method: iterative convergence. Gauss-Seidel is an iterative method that often converges faster than Gaussian elimination, especially for a system where the matrix is diagonally dominant or symmetric positive definite. Memory efficient. The method updates value iteratively and does not require storing the entire metric system, making it more memory efficient, particularly for large sparse matrices. Applicability to non-diagonally dominant matrices. Unlike some other iterative methods, Gauss-Seidel can be applied to non-diagonally dominant matrix and may converge even when strict diagonal dominance is not present. Write algorithm or program for fourth order Runge-Kutta method. Okay, so let's start with the very first step, which is start. Then we will define the function xy. Then we will read the initial condition x0, y0, number of steps n, and calculation point xn. Then calculate the step, which is h equals to xn minus x0 divided by n. Then we will set the loop I equals to 0, in which we will find the values of k1, k2, k3 and k4 by k1 equals to h multiplied by f x0 y0, k2 equals to h multiplied by f x0 plus h by 2 comma y0 plus k1 by 2, k3 equals to h multiplied by f x0 plus h by 2 comma y0 plus k2 by 2, k4 equals to h multiply f x0 plus h comma y0 plus k3. In the next step, we will find the value of k by adding the values of k1, 2k2, 2k3 and k4 and dividing it by 6. Then we will find yn equals to y0 plus k, x0 equals to x0 plus h, y0 equals to yn, I equals to I plus 1. If I is less than n, repeat the loop, display yn as the result, then stop. Okay, so lastly we have to obtain Simpson 3 by 8 rule from Newton-Cotes formula. So for this we know that the formula for I is this right here, and where Cin is this whole thing. So we will put n equals to 3 initially, and I equals to 0, 1, 2 and 3 for I0 equals to 3h summation of lower limit I equals to 0 to 3 yi c1 3. So we have to find the value of I0 by this formula here. So for this formula we have to find the separate value of these variables. So let's find these values from Cotes number C03, C13, C23, C33. We will compute. So initially we will find out the value of C03, this right here, by this formula right here, and after solving this whole equation we will get C03 equals to 1 by 8 right here. This is basic integration. Similarly we will find the values of C13, which is gonna be 3 by 8. It is right here, and putting its value in equation 1 we will find C23 equals to 3 by 8, and similarly C33 equals to 1 by 8. Right here it is written. So then for check I0 equals to 3h by 8 in bracket y0 plus 3y1 plus 3y2 plus 3y3, I2 equals to 3h by 8, y3 plus 3y4 plus 3y5 plus y6. It is written right here. In the next page we will have the value of I3, which is 3h by 8, y6 plus 3y7 plus 3y8 plus y9. Now after adding all the equations we will finally get our value of In, which is gonna be 3h by 8, y0 plus yn plus 3y1 plus y2 plus y4 plus y5 plus y7 plus y3 plus 2y3 plus y6 plus dash 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 to the yn minus 3. And this is the Simpson's 3 by 8 rule. Thank you.